Hello everybody! Today we're going to do factoring methods for the second day. So we've been talking about this idea of factoring and finding out what was multiplied to create an expression. So it undoes the multiplication process. Today we're going to take a look at two other methods, the other ones that are in your foldable. So you'll need that as well as a calculator and something to write with. So if we take a look at that foldable that we've already done or started, remember factoring, what does it mean? It means we're looking to undo the multiplication process. We're going to find out what was multiplied to create that expression. Greatest common factor is when you divide something out of every term. And factor by grouping we've already done with the whole 4 squares, stick them in the 4 boxes, take out a greatest common factor. So today we want to learn the last two, the AC method and the difference of perfect squares. So trinomial factoring is what the AC method is used for. Trinomials are these expressions that have 3 parts. You can see x squared minus a 6x minus a 16. This is a trinomial. So to begin trinomial factoring, we're going to take a times c to get things started. And then what multiplies to make that number and adds to make the middle term. And we're going to turn it into a 4-term grouping problem. So we're going to use the whole 4 boxes that we've been using since yesterday here. So if you write those descriptions in your notes here, we're going to start with that beginning part. Take a times c to get it started. A and c are referring to the terms, the numbers that are in the terms. A will always be in front of the x squared, and c will always be the constant or the regular number at the end. So take a times c to get it started. So this 3-term trinomial here, I'm going to take the a times the c here to get it started. So negative 16 times positive 1. Negative 16 times positive 1 is still negative 16. Now this number plays an important role in what we do. What multiplies to make that number? Well, lots of things multiply to make negative 16. There's negative 8 and 2, negative 2 and 8, negative 4 and 4, negative 16 and 1. You get the idea. But we're looking for the pair that multiplies to make that number, multiplies to make negative 16, and adds to make the middle term. So we want the pair that adds to make negative 6. So if I look through my list that I started creating here, negative 8 and positive 2 are the same thing as negative 6 when I add them together. What that means is this trinomial, or this 3-term piece here, expression can be rewritten as a 4-term problem. So if we keep the x squared and we keep the negative 16, but we rewrite that middle term as something that's equivalent. So the negative 8x and the positive 2x, negative 8 and positive 2, remember, are coming from our list. This expression is still the same. Negative 8 and positive 2 still makes negative 6x. But we've rewritten him here in a way that allows us to put them in the 4-term boxes here, and we can factor like we were doing yesterday. So I'm going to place the x squared in, the negative 8x, the positive 2x, and the negative 16. So if I now factor by grouping, take out something common from the first row, x, take out or divide out something from these 2 terms, a positive 2. What can I divide out of those 2 terms? An x. What can I divide out of these 2? A negative 8. So my final answer is x plus 2, x minus 8. These are the 2 pieces that were multiplied to create x squared minus 6x minus 16. Okay, let's take a look at this other example over to the side. 3x squared plus x and subtract 2. Again, 3 pieces to start. Let's do the AC method. A times c to get it started. 3 times negative 2 is negative 6. What multiplies to make negative 6? Again, lots of things. Negative 6 positive 1. Oh, what about negative 1 positive 6? Oh, what about 3 and 2, negative 3 positive 2, negative 2 positive 3. There's lots of options. But I'm looking for the possibility or the option that adds to make positive 1, since that's in front of the x. Positive 1 can be added if I take negative 2 and positive 3. So I'm going to rewrite this problem in 4 terms rather than keeping them with 3. So the 3x squared, the minus 2, the a and the c stay constant there, or stay the same. And I'm going to rewrite them with negative 2x, positive 3x from my list. They still make 1x if I were to combine them together, but I actually want them separate because I want to organize them into 4 squares. 3x squared minus 2x, positive 3x, negative 2. And again, factoring out, I can divide an x, I can divide a 1 out of this row. Going up here, I can take a 3 and an x out. And up the second column here, I can divide by a negative 2. So my answer is 3x minus 2 times x plus 1. Those are the two expressions that were multiplied to create the starting expression. This is the AC method, okay? We're going to use this quite often for the rest of the semester. Let's take a look at the last method here. The last method is called the difference of perfect squares method. I have up on the top there what you need to write. It's kind of light. It says identify if you have a difference, if you have two perfect squares, and then we can use it to factor into two pieces or into two factors. So I have 4 examples here. This idea of understanding that you have a difference means you have a subtraction problem. And then the second part is two perfect squares. These are numbers that you know the square root of, that can easily be square rooted, if you will. You worked with these a lot in geometry, like 25, because the square root of 25 is 5. So we're going to be looking for this pattern where we have a difference and where we have perfect square numbers. So take a look at this first example here. X squared minus 16. I'm noticing right away that 16 is a perfect square and that I do have a subtract sign right here. And that the number 1 in front of the x squared is in fact a perfect square as well. By knowing this, I can automatically factor him into his two pieces. What times what would make an x squared? Well, these have to be x's in order to make that x squared happen. And now let's talk about the 16. What is the square root of 16? 4. 4 times 4 makes 16. But remember, I need to make a minus 16 or a negative 16. So one of these needs to be positive and one of these needs to be negative. And again, you can check it if you want by distributing these out. X squared minus 4x plus 4x minus 16. If I combine like terms, it is x squared minus 16. So we did factor it correctly. I'm going to erase that work here because we don't actually need it, but it's a check. Okay, let's look over here at example 2. This is 4x squared minus 9. Again, I'm noticing the subtraction. I'm also noticing that 9 is a perfect square, as is 4. So I can factor these right away. The square root of 4 is 2, so this is going to be 2x. 2x. 2x times 2x makes 4x squared. 9 is 3. 3 times 3. One's positive, one's negative in order to make the negative 9. Done. It's factored. Let's do the third example. 16x squared. 4x times 4x. 4 times 4 makes 16, and x times x makes x squared. 25. His square root is 5. One positive, one negative. It doesn't matter where you put the plus and the minus. They're going to be the same. So your final answer, 4x plus 5, 4x minus 5. Let's look at the fourth example here. 4x squared minus 7. Well, I see 4 is a perfect square. I see the subtract sign. But think about what's wrong with the 7. He's not a perfect square. So this cannot be factored. Because 7 is not a perfect square. So be thinking about that. Not everything is factorable. Okay? We're going to take a look and practice some more at these two methods tomorrow. Thank you for watching and taking good notes in your foldable.